You ever stop and think about what's actually in the water we drink, or the water that grows our food? For the longest time, getting a straight answer was slow, complicated, and super expensive. But today, we're going to look at a smart, connected approach that's changing the whole game, giving us a real-time window into the health of our most critical resource.
Okay, so let's just dive right into why this is so important. Get this. According to the Journal of Nonlinear Analysis and Optimization, a mind-boggling 80% of the world's wastewater gets dumped without any treatment. Think about that. That's a massive, global problem. And it really sets the stage for why we don't just need a better way to monitor our water, we absolutely depend on it.
So this is really the heart of the story today. It's the old way versus the new way. On one side, you've got the traditional method. You grab a sample, you ship it off to a lab, and then you wait. It's slow, it's expensive, and you're always reacting to problems after they've happened. But on the other side, you've got the IoT approach. We're talking on-site sensors feeding you data instantly. It's fast, it's affordable, and it lets you get ahead of problems before they even start.
Now, to really appreciate just how big a deal this new solution is, we first have to understand why the old system is so, well, broken. Let's break down the challenges.
What's really interesting here is how all these problems create a domino effect. First, someone has to physically go out and collect samples, which takes a ton of work. Then, analyzing them in a lab takes forever. All of that costs a lot of money, right? Which means we can't test nearly as often as we should. So when something bad does happen, like a contamination, we're already behind. We're always looking at a single snapshot from the past instead of seeing the whole movie of our water's health.
But what if you could see that whole movie in real time? Well, this is where the Internet of Things, or IoT, steps in, offering a system that is always on, always watching, and always reporting back.
So what even is an IoT water monitor? Don't let the name scare you. In the simplest terms, it's a small, smart gadget that you just place in the water. It's loaded with sensors that are constantly measuring the stuff that matters. Then it uses a tiny little computer, a microcontroller, to zip that information over the internet to the cloud so you can see it on your phone or your laptop literally anywhere in the world. So the mission statement for this technology is pretty clear, and it's ambitious. The idea is to make monitoring cheap and automatic, to catch contamination the second it happens, and to make all that data accessible from anywhere. The end goal? To create a system that can be used everywhere, from a single-family home to a sprawling farm to a massive industrial plant. All right, so how do these little monitors actually work? It might seem super complex, but when you look under the hood, the anatomy is surprisingly simple. Let's pull it apart.
The easiest way to think about it is, kind of like a living thing. It has a brain that does all the thinking and processing, and it has senses that are constantly out there gathering information from the world around it.
The brain of this operation is a tiny but really powerful chip called the ESP32. It's basically a computer on a chip, and it's perfect for this job because it's cheap, it's powerful, and, this is the most important part, it has Wi-Fi built right in. That's the magic that lets our little monitor talk to the internet.
And if the ESP32 is the brain, then the sensors are its eyes, its ears, its nose. You get the idea. Each one is a specialist, designed to detect one specific, crucial thing about the water. Let's see what they're looking for.
So you've got a pH sensor. Think back to high school chemistry. It checks if the water is acidic or alkaline. The turbidity sensor is just a fancy way of asking, is the water clear or is it cloudy and murky? Then there's the TDS sensor, which measures total dissolved solids, a fantastic indicator of overall purity. And finally, a simple temperature sensor, because temperature actually affects all the other readings. Put them all together, and you get a really comprehensive health checkup for the water.
And this diagram just pulls it all together beautifully. See, over on the left, you've got the sensors, our senses, feeding all that raw data into the brain in the middle, that ESP32 chip. The brain then crunches the numbers, turns them into something useful, and sends that info out over Wi-Fi to the cloud. It's just a really elegant and efficient flow of information.
Okay, so we know all the parts now. Let's actually follow a single piece of data on its incredible journey, from a drop of water all the way to your screen.
It all starts when the sensors take a reading. Instantly, that ESP32 brain converts the raw signal into a number we can actually understand, like, say, a pH of 7.4. It might flash that on a little screen right on the device. Then, boom, it connects to Wi-Fi and shoots that data up to a cloud service. And just like that, the number pops up on a dashboard where anyone can see what's happening in real time. It's a totally seamless trip.
And here, you can see that whole journey made real. On the left, that's the physical hardware itself, the brain and its sensors all wired up. And on the right, that's the payoff. A clean, simple web dashboard showing the live data that same exact hardware is collecting at that very second. That right there is the magic of IoT, connecting the physical world directly to the digital one.
So, the theory is solid, the design is smart, the technology is cool. But the one big question remains: how does this thing actually perform out in the real world?
This is really the moment of truth, isn't it? Can this little device, with its tiny brain and its collection of senses, actually tell the difference between clean water and dangerously contaminated water? Let's take a look at the data.
Okay, now this is fantastic. The researchers tested 3 different samples. For pure distilled water, you can see the system reported nearly perfect numbers. Status, excellent. For regular tap water, the values were all well within the safe range. But then, look at the contaminated sample. The pH is way off, the dissolved solids are through the roof, and the turbidity, the cloudiness, is crazy high. And the system correctly flagged it right away, unsafe.
And here's the real kicker. Not only was it spot-on accurate, it was incredibly fast. The time it took for that reading to go from the sensor in the water to the dashboard in the cloud, just 1.2 seconds. That is the very definition of real-time monitoring.
So look, this isn't just some cool tech project. The implications of getting this right, of having cheap, accessible, real-time water monitoring are absolutely massive.
I mean, just think about the possibilities here. You could have one in your home to make sure your family's water is safe. Farmers could use networks of them to use water more efficiently. Factories could monitor what they're releasing. Environmental groups could watch over entire rivers. This kind of tech directly helps us tackle the huge UN goal of clean water and sanitation for every single person.
And ultimately, that's what this is really all about: empowerment. It's about taking critical environmental data that used to be locked away in expensive labs and putting it directly into the hands of the people, the communities, and the industries who need it most. It's the democratization of data.
And that leaves us with a final, pretty powerful thought. For pretty much all of human history, our water has been silent. This technology, for the very first time, gives it a voice, a way to tell us second by second exactly how it's doing. The only question left is, what incredible, important, maybe even uncomfortable things are we going to learn when we finally start to listen?